So now we see next problem, which is about equating area to find out area. Okay, we continue with this pattern and see the next problem. So this problem appeared in CAT 2018. Okay, let's understand what is the problem saying. Given an equilateral triangle T1 with side 24, second triangle T2 is formed by joining the midpoints of T1, then third triangle T3 is formed by joining the midpoints of the side T2, and if the process of forming triangle is continued, sum of the area in square centimeter of infinite such many triangles T1, T2, T3 will be what? Okay, so as soon as I see this, I know there's a problem on GP, geometric progression. Sum of infinite series is what? A upon 1 minus R, where A is the first term and R is the common difference. Okay, I'll have to reach to this first to get to my answer. So let's reach to this. Let's first make the diagram and understand what is being given here. So I am being given an equilateral triangle, means all the three sides will be equal for this triangle. The side of this triangle is 24, so all these sides are equal to 24. Now I draw one more equilateral triangle inside this, where the vertices are touching the midpoints of this. So if I say this is a midpoint, this is a midpoint, and this is a midpoint, which means what? This distance would be 12 if from here. So will this distance be 12? From each of the side, you can think in that way. So I made one more equilateral triangle. So let's make one more equilateral triangle with this 3 points, the midpoints as the vertices of this triangle. So I make a triangle here which becomes something like this. Okay, that is my second equilateral triangle that I put in inside this triangle. So what will be the side of this triangle? First understand that. What will be the side of this triangle? This triangle is nothing but, if I paint it here, this is this yellow triangle. Right? What is the side of this yellow triangle? As you can see it here, the side of this is 12 and it's an equilateral triangle. All three sides would be same. So the side what of this is also 12. I know that, okay, because it comes from midpoint. So all the three sides are 12 for all the three yellow triangles. I don't want the yellow triangle. I want this blue triangle. Even for the blue triangle, all the three sides would be same. Right? 12, 12, 12. Because it comes from here only. And that is quite understandable. If you cut this, it comes from here only because it's a midpoint. Right? So this will again be 12. It's a midpoint. This will again be 12. It's a midpoint. So all this three yellow as well as the one blue are equilateral triangle with side 12. You can say one big equilateral triangle of side 24 is cut into four equilateral triangle of side 12. That is one way to look at it. So if you understand from this, what are you doing? You are drawing now one more equilateral triangle inside this. So just for your idea, I'll draw one more. So if I take the midpoint of this and I draw one more equilateral triangle like this inside this. Now what will be the side of this? You understand the side is becoming half every time. So if I draw an equilateral triangle like this, I know this is 6. So this side has to become 6. Okay, which is, let me just color it again, would be this red triangle. Okay, I don't want this red one, but I want this green one. Doesn't matter. The side of that will be 6. So what do I understand? As soon as I go inside, the side becomes half. The outermost triangle at 24, then 12, then 6. Next will be 3. Then it will be, after 3, it will be half of 3, okay, which is 1.5, and then so on. It'll keep on going like this. So if I have to put this in formula, I know the side of an equilateral triangle first is 24. So the area, he's asking me sum of area of all such equilateral triangle T1, T2, T3 up to infinity. So the area of the outermost equilateral triangle is square root of 3 by 4 into side square, where side is nothing but 24. Right? Similarly, the area of the next equilateral triangle will be what? That will be equal to square root of 3 by 4 into side square. Side is nothing but 12. So 12 square. Area of next equilateral triangle will be square root of 3 by 4 into side square. Side is nothing but 6 square. Side is becoming half every time. That's what you understand. 24, 12, and then 6. And going on like this. So from this I understand, if I know about GP, I'll just take out square root of 3 by 4 into 24 as a common from here. let's keep 24 there. Okay, that will be much easier. So square root of 3 by 4 I take out common from here. Okay, so what is remaining then? Inside the bracket I have 24 square plus 12 square plus 6 square, going like this up to infinity. Right, so now I understand this is nothing but a GP. A GP where the first term is 24 square. The first term is 24 square. And the common difference is second term upon first term, that is 12 square upon 24 square, that is 1 by 2 the whole square. Right, if you do this whole square, 12 by 24 the whole square, that is 1 by 2 the whole square. So 1 by 4. That's your common difference. The sum of infinite terms in a GP is A upon 1 minus R. A is nothing but the first term. So I'll write the first term, that is 24 square. So 24 into 24. A upon 1 minus R. R is nothing but the common difference here, which is nothing but 1 by 4. So let's write it here, 1 by 4. Now I got my answer. Okay, this entire thing is being multiplied by what? Let's write it here. Square root of 3 by 4. Okay, how do I get this? It comes from here. Okay, this is this. This is this. And rest of the things, the sum of this is written as this. So all looks good now. Okay, let's solve this to reach on to our final answer. So as you solve this, this will become what? 24 into 24 into 1 minus 1 by 4 is 3 by 4. So this becomes into 4 by 3. And this is square root of 3 by 4 from here. So what happens? 4 gets cancelled. You have a root 3 here in the denominator. Okay, or else you can say, let's cut this. 3 ones are 3 8s are to match the options. So 24 into 8 is what? 28 is 160 plus 32, 192 square root of 3. Option number D is your answer. Okay, so a simple problem. You just have to understand. You can solve this problem like in 1 minute, okay, or less than that, because you have to understand every time you do that, the side of the equilateral triangle is becoming half. So eventually square root of 3 by 4 will come inside, 24 square, 12 square, 6 square. That is 1 by 4. If you see the D with the first term as 24 square. As soon as I see this, just write this in exam and reach on to the answer. No need to do all these things. This is just for your understanding. You see the figure, you write this thing, within a minute, you reach on to the answer and mark the option. Okay, that's how easy it would be now to equate area and find the area in this case. So now we solve one more problem which is based on the same pattern, equating area to find out area or length. Okay, so what are we supposed to find out here? Length. So we equate area to find out either area or length. In this case, we find out length. Okay, so this problem appeared in CAT 2003. So let us understand what is being given here. The internal bisector of an angle A in triangle ABC meets the side BC at point D. EB is given, AC is given, and angle A is given. Then what is the length of the bisector AD? Okay, so I have to think now which formula of area will I apply? Circumradius, in radius, half into base into height, square root of S into S minus A, S B S minus C, half AB sine theta. Let's think. So I'll first start by making a simple triangle here, which would be this. Internal bisector of angle A. So let's say that this is A and this is B and this is C. So this internal bisector meets PC at point D. So this is an angle bisector. Okay, understand what is this? This is an angle bisector. And I'm given that angle A is equals to 60 degree. This angle is equals to 60 degree. And this is an angle bisector. So it will split this angle into what? 30 degree would be this and 30 degree would be this. Okay, that's how it will be split up. And this point here is given to me as D. What else do I have now? If AB is equals to 4, so this length is given to me as 4. And AC is equals to 3, so this length is given to me as 3. And I'm being asked what is AD. Okay, so this length of AD is something that I'm supposed to find it out here. So given this condition, which formula will I use to reach on to the answer? Okay, that's what I'll have to think. I know a formula, okay, which is if this side is A in this triangle, if this side is A, this side is B, and this angle here is theta. So what is the area of this triangle? Can you find this out? Yes, this is equals to half into A into B into sine of theta, right? We know this property. Let's apply it here to reach on to the answer. So again, equating areas to find out the length. So what will I say? See, area of triangle ABC, let's understand. Area of triangle ABC is equals to what? Area of triangle ADC, okay, plus area of triangle ADB, correct? Sum of the parts is equals to total. This triangle plus this triangle is equal to the bigger triangle. So if I color this, say this is a green triangle and this is this yellow triangle. So green triangle plus yellow triangle will be equal to triangle ABC. So if I can find their individual areas, I can sum them and I can get the area of this. But that is not what we are supposed to do. That will help us to find out AD. That's what we are doing, equating the areas to find out AD. Let's see how will this help us. Think about this. What is area of triangle ABC? If I write it in terms of that formula, that will be easy. This C, this one and this one, and this the angle theta. So half into 3 into 4 into the sine of the angle between the two sides, which is 60. So area of triangle ABC will be half into 3 into 4 into sine of 60. Okay, and what is sine of 60? Just remember sine 30 is half. So sine 60 is square root of 3 by 2. So I write it here. Okay, this is nothing but your sine 60. Applying the same formula. Half AB sine theta. Now for green triangle, let's say EDC. What is, if you apply the same formula, what will it be? Half into, now let's understand. Okay, visualize this. This is the triangle. So half into 3 into AD into the sine of angle between the two sides, that is 30. So that's what I'll write it here. Half into 3 into AD. AD is something that I'm supposed to find out. That's what I'm equating areas to find out length. Into the sine of angle between the two sides, which is sine 30. Sine 30 is nothing but half. So let's write it here. Plus for the yellow triangle, it will be what? Half into 4 into AD into the sine of angle between the two sides. So half into 4 into AD into sine 30. Sine 30 is nothing but half. Okay, just know this basic triangle. Sine 30 half, sine 60 root 3 by 2, sine 45 1 by square root of 2. That will help you to reach out to the answer to such question. Now what? You have an half everyone. Okay, so let's take this half as common and let's cut this. So if I take half as common, it will be cut from here, it will be cut from here, it will be cut from here. What are you left with now? I'm left with 2 ones are 2 twos are 4, 2 into 3 is 6 root 3 from here. Okay, what are you left with here? 3 by 2 AD. And what are you left with here is 4, 2 AD. Okay, that is equal to 2 AD. 2 ones are 2 twos are 4. Okay, that's all you have till now. Now what? Now just solve this to reach on to the answer. So finally, if I solve this, this becomes what? 2 plus 2, 4 plus 3, 780, okay, upon 2 is equals to 6 root 3. If I multiply this 2 here, that will become what? Into 2. That becomes 12 root 3 is equals to 780. AD is equals to what then? AD is equals to 12 root 3 divided by 7. Your answer. Okay, which is option number A. So again, a very simple problem. You just need to visualize which formula of area will you use to find out this length. Okay, once you are clear with that, you can reach on to the answer easily for this problem.